Hi, hello everyone. Welcome to Next Gen Academy. This is Madhusudan, Department of Physics. Today we are going to discuss one interesting topic, that is relative velocity. Usually students ask me that, sir, relative velocity is a tricky topic. How to handle the questions in an easy way? How to handle the directions of relative velocity in an easy way? These are all the questions usually students ask me. So today, let me take that relative velocity concept. After this video, you can handle the questions of relative velocity very easily, right? So without wasting the time, let me start the topic, that is relative velocity. Here we go. Relative velocity is our topic. Relative means comparison. Relative means comparison. Velocity, so nothing but comparison of velocities. Usually, suppose if you get marks 540 out of 600, 540 out of 600, and your friend has got 550 out of 600, your parents used to scold you that you got 10 marks less than your friend. So there they are comparing your marks with your friend's marks, which means the comparison. That comparison is nothing but relativity in case of marks. Similarly, velocities, if you take velocity of one body with respect to another body is called relative velocity, which means suppose you are observing one body's velocity with respect to other, that is nothing but relative velocity. So let me explain this simple concept with the help of one example. Have a look at this. Here we have a platform. Let me take it is a rest. This platform is at rest. This body, suppose this is the body, first body, which is A. Let me take it is A, and it is moving along this x direction with 20 meter per second. I am assuming this is along positive x direction. And the second body, here it is. Let me imagine this second body is B. This second body is also moving with certain velocity, that is 8 meter per second. 8 meter per second. These two bodies are moving on the ground, and suppose here we have an observer who is at rest. This is the observer. This observer is at rest. This observer is at rest. Now, with respect to the observer, that observer is observing this first body first of all. As a result, what's the velocity observed? Means velocity of this A, velocity of this first body A with respect to ground, is equal to 20 meter per second, which means this observer is on the ground, he is at rest, and the body is moving. As a result, he feels that it is moving with 20 meter per second. Nothing is here. So a simple observation. And then coming to the observer, second observer, what's the velocity of this observer B with respect to ground? Velocity of B with respect to ground, which is equal to 8 meter per second. This is the observation of the observer who is at rest. This observer also at rest. Okay. Now, the question here is, relative velocity means if the observer is on A and he is observing velocity of B. For example, here, look at this. Now, observer is on the first body. He is the observer. So, this observer is observing this body, which means we are observing velocity of this B with respect to A, velocity of this B with respect to A, that is this B velocity we are finding with respect to A. So why do you write this? Because observer is on that first block, so we are measuring velocity of this block with respect to block A. This is equal to velocity of B minus of velocity of A, which means this can be rewritten as velocity of B with respect to ground, means with respect to platform. Which is the platform here? The platform is ground. So I am taking velocity of B with respect to A is equal to velocity of B with respect to ground minus velocity of A with respect to ground. Sir, why do you take with respect to ground? Because we assume the bodies are moving on the ground. So the platform is ground and that ground is at rest. So both the bodies are moving on the ground. So let me take it is with respect to ground. If you substitute the values, now here VBA is equal to anybody? If it is the question VBA, if we ask 8 I cap minus of 20 I cap this is equal to minus 12 I cap. So this negative sign we got, what it indicates? What it indicates means this body B is traveling slower than body A. So we are getting negative sign. Same question if we take in reverse manner. Reverse manner means what is the relative velocity of A with respect to B? A with respect to B means, let me take with small changes in the diagram. Right. Look at this. Here we have body A moving with 20 meter per second and this body B moving with 8 meter per second. Now where is the observer? Observer is on B. He is observing. This observer is observing the body A. So therefore velocity of A, where is the observer? Observer is on block B, which means with respect to B. So therefore velocity of A with respect to B, is equal to VA. This VA means what? VA with respect to ground, because this body is moving on the ground, minus of VBG minus of VBG in this. So here if you substitute the values, here we have what is velocity of A, that is 20 I cap minus of 8 I cap, which is equal to 12, which is equal to 12 I cap is the answer. 20 I cap minus 8 I cap is equal to 12 I cap. So here if you compare both the problems and have a look at this. Both the problems, if you compare the situation, minus 12 I cap here in the first case VBA and VAB is plus 12 I cap, which means magnitude wise both are same, directions wise they are opposite. That is, which body is moving faster, which body is moving slower, that's the concept, right? Usually we observe this kind of situation in case of trains. Suppose yourself and your friend are traveling in two trains but separately. One is moving with 100 kilometers per hour, yourself, and your friend parallelly on another train, means which is traveling with 80 kilometers per hour. You may feel you are moving faster than him 20 kilometers per hour. Your friend may feel yourself traveling faster 20 kilometers per hour. So this is what a relativity, right? This kind of situation you can feel in real time also. This is what the concept of relative velocity in a simple manner. Let me take another example here. Which explains relative velocity in a detailed way. Another example, have a look at this. Another example here. Now, if both the bodies are moving in the opposite manner, suppose this is body A and it is moving with certain velocity 10 meter per second, imagine. Another block is moving with certain velocity as 8 meter per second, imagine 8 meter per second. This is the block B. These two blocks are moving in the opposite manner. Then what's the relative velocity? Formula wise it is same. That is, relative velocity of A with respect to B is equal to VA minus of VB. VA minus VB. This is the formula. So I am assuming here actually this is the direction, positive direction I am taking, and here it is negative direction I am taking. This is the usual convention I am following. Okay. Now tell me velocity of A. Velocity of A, is it in the negative direction or positive direction? Here it is. A is in the negative direction. So you can write -10. B is in the positive direction. So as it is formula wise it is negative, and so therefore it is 8 meter per second. This is equal to minus 18 meter per second is the relative velocity of A with respect to B. A with respect to, which means these two blocks are actually separating, moving away from each other. Away from each other, how faster they are separated. This is what relative velocity of separation. The two bodies are separating each other. How faster they are separating. So here in this context, they are separating with 18 meter per second. 18 meter per second, they are separating each other. Okay, right. Now, another question I'll take. Another question I'll take. Have a look at this. Now, another question. Have a look at this. Here also, both the bodies are moving in the opposite manner. Let me take it is A, and it is moving with 10 meter per second as usual, like in the previous question. Here it is another body, block B, is moving with certain velocity 8 meter per second. But these two bodies are moving towards each other. Earlier in this question, the two bodies are moving away from each other. Now in this question, the two bodies are moving towards each other. So therefore, here the bodies moving towards each other means relatively the distance between them decreases. So this is called a relative velocity of separation. Relative velocity of separation. So here, if you want to find velocity of A with respect to B, velocity of A with respect to B, this is usual convention I am following in this way. This is the direction of positive x direction, and here it is negative x direction I am following. This is the convention. Therefore, VAB is equal to formula wise VAG minus of VBG. This is equal to VA as 10 minus of minus 8, because block B is moving along negative y direction, negative x direction, and so therefore I am taking negative sign here. Overall, it is equal to 18 meter per second. Overall, it is 18 meter per second. In this case, relative velocity is equal to VAB. Now, if you observe the previous question and this one, in the previous question we got negative sign because that is relative velocity of separation. Here the two bodies are approaching each other, we got negative sign, which means distance between them is reducing. Relative velocity of approach it is. So that is VAB is equal to 18 meter per second. Clear? Okay. Another kind of question here in case of relative velocity. Look at this. If the platform itself moving, what happens? Platform itself moving, what happens? For example, here we have the platform, nothing but a ground. On the ground, we have a vehicle. Let's imagine this is the train. In this way, this train is moving with a speed of 10 meter per second. Over this train, one particular person is running in this way with certain speed 2 meter per second with respect to train platform. With respect to train, this particular person is moving with 2 meter per second, whereas the train itself moving 10 meter per second. Now the question is, what is the velocity of the person with respect to ground? Now here we know that relative velocity means velocity of A with respect to B is equal to velocity of A with respect to ground minus of velocity of B with respect to ground. This one is velocity of A with respect to ground is equal to velocity of A with respect to B minus of VBG. Minus of minus becomes plus. This is the formula, right? So whenever you want to find the velocity of one body with respect to ground, means that velocity of A with respect to ground is equal to VAB plus VBG. VAB plus VBG, this we have to take. Okay. Now look at this. Look at this. In this context, velocity of this person with respect to ground, just like VAG, we are finding here, this is equal to velocity of the person with respect to train plus velocity of the train with respect to ground. Just we are using the concept of relative velocity. So observe the problem carefully. This person is running over the train with a speed of 2 meter per second. This 2 meter per second is with respect to ground or with respect to train. That is with respect to train. And this 10 meter per second, it is the velocity of the train with respect to ground. So here we have, this is equal to 2 meter per second, velocity of the person with respect to train, plus velocity of the train with respect to ground, which is equal to 10. Overall, it is 12 meter per second, which means velocity of the person with respect to ground is equal to 12 meter per second. 12 meter per second. So if you are observing, means an observer is stationary. If the observer is on the ground and he is observing in this way, so he can feel, this observer can feel that this particular person is moving with a speed of 12 meter per second with respect to ground. Okay, this is situation whenever platform itself moving, where the person or object is moving, that platform itself moving, means this kind of formula you have to apply. This is the method. Same method or the same kind of formula is applicable for the boat and a river, or for a man swimming in water or in a river. Same thing is applicable. Let me take that example also. Now look at this. Here, imagine this is the water surface, liquid surface or water surface you can take. This water is moving with certain velocity. Imagine this water, velocity of this water with respect to ground. Velocity of water with respect to ground is equal to 10 meter per second. 10 meter per second. Over this water surface, imagine one boat in this way. This boat is traveling. Velocity of this boat with respect to water surface is equal to 5 meter per second. 5 meter per second. Okay. Now the question here is, what is the velocity of the boat with respect to ground? This is the question. Velocity of the boat with respect to ground. If this kind of question is asked, we have to use relative velocity. So how do we use relative velocity to solve this kind of questions? Means, as you observe clearly, on the water this boat is moving. Imagine this boat as an object. This object is moving on a platform. Which kind of platform? This platform is at rest or moving. This platform itself moving. So therefore, it is similar to the man running over the train, right? So let me write the formula of relative velocity. Velocity of boat with respect to water, which is equal to velocity of boat with respect to ground minus of velocity of water with respect to ground. This is the formula. Now, as of now, we need this quantity, velocity of boat with respect to ground. So that is VBG is equal to VBW plus VWG. In this way, we can use the concept of relative velocity to find the velocity of boat with respect to ground. Now, if you substitute the values here, tell me here velocity of boat with respect to water. With respect to water, velocity of boat with respect to water, it is 5, and velocity of water with respect to ground, it is 10. So therefore, this is equal to 15 meter per second. 15 meter per second. That's the velocity of the boat with respect to ground. Even if the platform is moving, this is the method of finding relative velocity. Okay, right. So let me take some questions on relative velocity, which strengthens your conceptual knowledge on relative velocity. Here we have a question. A car A moves with velocity 20 meter per second and car B with velocity 15 meter per second as shown in the figure. Find the relative velocity of B with respect to A and also A with respect to B. Both the questions are given. Relative velocity of A with respect to B, also velocity of B with respect to A. Both of the questions we have to answer. So the formula which we have is VAB is equal to VA minus of VB. This is relative velocity of A with respect to B, and relative velocity of B with respect to A is equal to VB minus of VA. Similar kind of formula in this way. So first part of the question is relative velocity of B with respect to A. This one is the first part. VBA is equal to VB minus of VA. Vectors, because velocity is a vector, vector notations we have to follow. Now this is equal to, have a look at the diagram. Velocity of B means first this one, car B velocity is 15 meter per second and car A velocity is 20 meter per second. So therefore car B is moving with a velocity 15 meter per second and car A is moving with a velocity of 20 meter per second. So this is 15 minus 20, which is equal to minus 5 meter per second, minus 5 meter per second. We got negative sign, which means this car A is moving faster than car B here. So therefore we got negative sign, right? Okay then. Now look at the second part of the question. Second part of the question, that is VAB is equal to VA minus of VB, which is equal to VA is 20 meter per second and minus of 15, VB is 15, which is equal to 5 meter per second. Magnitude wise both are same, direction wise they are opposite. That's why we are getting negative sign in case of first part and positive sign in case of second part. So this is the relative velocity of car A with respect to B. Here it is, and car B with respect to A. Here this car is moving slower. How much of slower it is moving means it is moving 5 meter per second slower than A. So we are getting negative sign. So here it is minus 5 meter per second. It indicates car B moving slower than car A. That's the meaning of negative sign here. Okay. So let me take the next question on this. Right. So look at the next question here on relative velocity, same concept. A small change. The two cars are not moving in the same direction. They are moving in the opposite direction. So first car A is moving with 15 meter per second in this direction. Let me take it is negative x direction. And car B is moving in the positive x direction with a speed of 20 meter per second. So here also we have to find relative velocity of B with respect to A, also A with respect to B. So concept wise the same, formula wise same. Relative velocity of A with respect to B is equal to VA minus of VB. And similarly VBA is equal to VB minus of VA. Same kind of concept, same kind of formula we can apply. Now here it is, first part of the question. Let me solve first part of the question. That is velocity of B with respect to A, that is VB minus of VA, which is equal to velocity of B equal to 20 meter per second. 20 meter per second. Here it is 20 meter per second. Minus of VA. Minus of VA. This VA is moving in the opposite direction of B. So therefore we have to take minus of this velocity, that is minus of 15. Already formula wise negative sign we have, minus of 15 we have to take. Overall this is equal to 20 plus 15, that is equal to 35 meter per second is the relative velocity of B with respect to A. Okay, same formula, but here we are getting positive sign because the two bodies, means two cars, are moving in the opposite direction. Okay, right. Now let me take the second part of the question. Second part of the question is relative velocity of A with respect to B. A with respect to B. So that is V AB is equal to VA minus of VB. This is equal to VA as minus 15 because it is along negative x direction. If you want, you can write in this way. Next, minus of 20 I cap, that is equal to minus of 35 I cap. Magnitude wise both are same, direction wise they are opposite, so we are getting negative sign here. Okay, so that's the difference. These two cars are moving in the opposite manner. Values wise, earlier previous question and this one both are same. So here magnitudes are changes because the cars are moving in the opposite directions, right? Okay, so look at the third question. Conceptually a tricky question, a very good question to strengthen the concept of relative velocity, right? So look at the question. A bird flies to and fro about two cars which move with velocities v1 and v2. These two cars are actually moving opposite directions in the sense both are moving towards each other with velocities v1 and v2 towards each other. And the next part of the question, if the speed of the bird is v3 over the two cars, the bird is moving like to and fro with a speed of v3, then and the initial distance of the separation between them is d, find the total distance covered by the bird till the cars meet. So first thing here is we have to find the time taken by the two cars to meet, so that within that time interval what's the distance covered by the bird we can calculate. So first thing is what is the time taken by the two cars to cover that distance, given distance d, as these two are moving in the opposite directions, that we have to find. Now two cars are moving in the opposite direction means what's the relative velocity of the two cars? Relative velocity, if you take velocity of first car with respect to second car is equal to v1 minus of v2, v1 minus v2. This is equal to magnitude wise these are v1 plus v2. Relative velocity magnitude wise I am writing v12 is equal to v1 plus v2. That's the velocity. And when it comes to the time taken is equal to, in general, velocity is equal to distance by time. Velocity is equal to distance by time. So therefore this time taken is equal to distance by velocity. This velocity is nothing but v12 relative velocity. So this is equal to distance between the two cars by relative velocity as v1 plus v2. This is the time taken by the two cars to meet. As the two cars are approaching each other, they are colliding, at some point they'll meet. So what is the time taken? This is the time taken. Meanwhile, the bird is executing to and fro motion. To and fro motion means first this bird is here and it is coming to here and then turns back, coming here, and then on reaching the car turns back. In this way it is executing to and fro motion, and finally at one point as the cars are meeting, this bird stops here. So what's the total distance traveled by that bird we have to find. So here same formula is applicable. This one is distance traveled by the bird is equal to here we have velocity of the bird into time taken. As this velocity of the bird is given in the question as v3, this v3 into time taken is equal to distance by v1 plus v2. This is the distance traveled by the bird before the cars meet. This is a good question which explains the relative velocity in a detailed way, and the two a good application here to understand relative velocity. Okay. So look at the next question. A person walks up a stationary escalator in a time t1 seconds. So look at this escalator. this is at rest, means stationary means rest. Usually we find in metro stations or railway stations or airports, we find this kind of escalator. Imagine this escalator is not working and it is at rest. This person is supposed to walk up that stationary escalator. So what is the time taken means? This person is taking a time of, here it is t1 seconds, takes a time of t1 seconds here. Now what's the velocity of the person on the stationary escalator here? Means v1 is equal to, first case it is, v1 is equal to, velocity means distance traveled by time taken. This is v1. Velocity in the first case. Second case, look at the second. If he remains stationary on the escalator, then it take him up in t2 seconds, which means person is stationary, but escalator is working right now. Imagine it is working and he is just standing, and so therefore this escalator is taking the person up in a time of t2 seconds. So what is the velocity of that person? Velocity of that person in the second case. v2 is equal to, lengthwise it is same, time taken is equal to t2. Third case, look at that. If the length of the escalator is L, then determine the speed of man with respect to the escalator. Determine the speed of the man with respect to escalator. Here it is, escalator speed means man speed we have to find with respect to escalator. Second part, determine speed of the escalator, and then how much time would it take him to walk up the moving escalator. Here it is, already first part of the question we solved, second part of the question also we solved. Coming to the third part, how much time would it take him to walk up the moving escalator. So as the escalator is moving, man is also walking up the escalator. So what would be the time taken? That we have to find, which means escalator is moving with a speed of v1 upwards, escalator is moving with a speed of v2, man is moving with a speed of v1, both are moving in the same direction, platform itself moving. So therefore velocity in the third case, v3 is equal to v1 plus v2. So why do you take v1 plus v2 here? Which means escalator is a platform, this platform itself moving, and this man is walking up the escalator. Both the speeds we need to add up here. So therefore v1 plus v2. Now L by t3 is equal to L by t1 plus L by t2, and that implies this L and L can be cancelled out. 1 by t3 is equal to 1 by t1 plus 1 by t2, or if you want t3 you can write in this way, t1 t2 by t1 plus t2, So here it is. This is the expression for the time taken, means the third part of the question t3. First part, velocity of the man L by t1, velocity of the escalator L by t2, and here this one, velocity, time taken by the man in the moving escalator, right? Okay, let me take the next question. Hope you understand this question. Next, look at this. This is also conceptually a good question on relative velocity. Now look at this. A ball is thrown downwards with a speed of 20 meters per second from the top of a building. This is the point. From this point, a ball is thrown with a speed of 20 meters per second from a height of the building 150 meters. Second part, simultaneously another ball is thrown vertically upwards with a speed of 30 meters per second. From this point which is thrown, and here it is from this point which is thrown. Here it is 20 meters per second downwards, 30 meters per second upwards. What we have to find here? Find the time after which both the balls will meet. So you tell me one thing, relatively what is the separation between the two balls or the two bodies? Actually, they are separated relatively by a distance of 150 meters. So therefore, what's the total separation? Total separation S is equal to 150 meters. Together they are traveling a distance of 150 meters. Okay, and then relative velocity of the two bodies, relative velocities of the two bodies is equal to v1 minus of v2. v1 minus v2 is equal to 20 minus of minus 30. That is because they are moving in the opposite manner. Therefore, minus of minus becomes plus, which is equal to 30. 20 plus 30, 20 plus 30, this is equal to 50 meter per second. 50 meter per second is the relative velocity. And coming to the relative acceleration AR is equal to acceleration of a body projected vertically upwards is equal to minus z. Acceleration of a body projected vertically downwards, including direction, that is also minus g. On both the bodies, acceleration due to gravity is same. So therefore, if you take subtraction, their relative acceleration becomes 0, which means minus g and minus of minus g, this is equal to 0, because both the bodies are under gravity, which means relatively with respect to one body, another body has no acceleration. Therefore, relative acceleration is 0. Okay, then what we have to find? Find the time after which both the balls will meet. Relatively, imagine this kind of a situation. This ball is traveling up to here. This is the position, and here it is traveling up to here, and they are meeting at this particular point. They are meeting. Imagine this is the position. So overall they traveled a distance of 150 meters. And now if you use the equation S is equal to ut plus half at square, for a uniform acceleration. Here acceleration itself not there, relative acceleration, and so therefore S is equal to how much? 150 meters. 150 meters is equal to, this is equal to, u is equal to how much? Relative velocity as 50, and the time taken we have to find, and this one is 0 because acceleration is 0, and that implies 150 is equal to 50 into t, and the time taken is equal to 3 seconds. So the two balls will meet after 3 seconds. So this is the situation. Using relative velocity, we can find the time taken by the two bodies. Or this you can take as a formula also. Time taken to reach the two bodies is equal to u by h by u you can take. H by u is the formula. You can use this concept or this topic as a formula also you can use to find the time taken by the two bodies to meet. Okay, right.